Hello and welcome to an introduction to Radians and basically an overview of Radians. It's a great video that I'd recommend watching. I'll put a link to it in the video description. It's better than I could ever explain, but it basically looks at what a radian is. So what we're going to be looking at firstly is this question here. So I'll just zoom in a little bit more on that. Okay, and this one assumes that you know how to do sine, how to find these exact values there. So we're going to just have a look at this example over here, and I'll just get my class pad up too. So we're going to be looking at using radians to help us solve trig problems. So in this question here it says solve for x to 2 decimal places. So what we have here is a right angle, so we can just use our normal right angle trig, except that we are going to be using radians instead of degrees. So we'd firstly go, okay, we need to choose our trig function. In this case, we have an angle here, 1.3, opposite and adjacent. So we're going to be using tan because of TOA. R for radians is equal to 11 over x. Okay. Now in this case here, let's just use a bit of algebra. We know the shortcut there is we can just swap these two. And then we can evaluate using our class pad. So in this case here, we'll just type this in, shift divide, shift 3. Before you press enter, check you're on radians, enter. Standard to decimal, there we go. So x is equal to 3.05 meters. Okay, now there's a few other ways you can do it. As you can see here, I've solved here 3.05 meters. Common mistake, I've shown it here. If you're in degrees, look at the answer you get. So if we press this again, 484 meters, and you can, this is a sanity check, right? Would this be 484 meters? Just double check your work there. And it definitely would be if it was degrees, but this is radians. So just make sure your calculator's in the right mode before you press the enter button. Okay, we're going to solve for x in the exact form here. So it's a NRAT using non-right angle trig, and we've got opposite pairs of sides, so we're going to be using sine rule here. Let's label a triangle A, B, C. Okay, so we've got A, and then we've got C and C. So we're going to be using x on sine pi on 6 is equal to 4 on sine pi on 3. Just let that load up. Now we've got to consider what those exact values are. So let's just say, for instance, this is a non-calc question. Let's firstly get rid of that sine pi on 6 by multiplying across. And let's just sub in and find out what those values are. Okay, so divide by sine pi on 3. So what's sine pi on 6? Well, we know sine pi on 6 is the same as saying sine 180 divided by 6, so that's going to be sine 30 degrees. Sine 30 degrees we know is a half, multiplied by 4, divided by, and sine pi on 3. Sine pi on 3 is going to be root 3 on 2. Just wait for this to catch up. There we go. Half times 4 divided by. Great. And then we just evaluate. Half times 4 is 2. Times by 2 on root 3. 4 on root 3. We don't like it like that, so what we do is we can just times top and bottom by root 3. What do we get? 4 root 3 on 3. Then add our units, centimeters. Okay, and there's our answer, right? Make sure you have your units. Let's just double check using our class pad. Now, if this was a calc question, your class pad can do this using exact form. So let's have a look. Shift, divide, cross, equals. Okay, and let's just plug in our values. We've got an x on shift 1, and then we've got shift divide, shift 0 for pi on 6. And this is obviously lazy daisy, like this is, you don't have to use your brain, you just have to put it in and just recognize its sine rule. But I'd recommend that, save your brain for the, more complex questions if you can. Great. Okay, now we've got 2.309. Now, we're in decimal mode right now. If we click to standard and press execute again, we see 4 root 3 on 3, which is exactly the answer we have. So our class pad's able to do that too. Okay, and that's the end of this video using Radians for NRAT and RAT trig.